We are now ready to perform inspection of any geometry on the part since we've been aligned. Right now, I would like to inspect this hole on the part, which happens to be hole E on this drawing, where we do have the cylinder we want to inspect, along with a couple of circles that are on top of that we want to measure diameter. So in this particular case, if we look at the part, for sure, with the way the probe is oriented right now, we won't be able to perform the measurement inside that hole. So one of the first things we have to do is figure out which tool orientation of the probe head we must use to be able to measure this. Now, in order to make a tool orientation change, it is very important that we make sure we clear the probe away from the part to avoid any collision. So for that, I'm going to create a go-to step like I did before, using one of the points we will find here. So we're just going to move a little bit further away from the CAD surface, so about 10 centimeters seems okay. And when I hit go, the machine goes to that particular location. And now I'd be ready to find the best tool orientation to measure this hole. I want to use a tool that's called Pick Tool Orientation that will allow me to simultaneously find the orientation that's already existing that best matches the location where this hole is, because it's not always obvious to be able to figure out which A and B values will be optimal for that particular hole. So in this case, if I pick here, I can say, so let me just close this, use the Pick Tool Orientation. The way the tool works is if you're making your cursor go on a surface, it's going to show you red if there's currently no tool that has been defined that matches the normal orientation of that surface. Remember here that we tried to pick probe orientation or tool orientation that is as normal as possible to the surface we'd like to measure. So in this case here, when you reach a location where you're going to get the proper angle or proper orientation from the list, you're going to see that the orientation becomes, and the arrow becomes green, which means that we do have this orientation and it has been properly calibrated. So if I pick here, you're going to see that the tool orientation is about to change. So now our probe is now in a different location, and it may be required or not required to do another go-to to send it to a position where it wouldn't collide with the hole we want to measure, which is this one here. So let's create our features and we'll see with the path if there's a risk for collision. So for now, let's create the features we need. So I'm going to begin with a cylinder that happens to be my datum E. So this one. And circles that are not necessarily datum, but I'm going to create a circle at the bottom here, circle on top, and circle at the bottom of the counterbore over here. So I have 3 circles, and I'm also going to create a distance between this circle here and this circle there to match the distance that we have here on the drawing. So I'm going to create that distance feature between circle 2 and 3. That is the distance I would need. And I will group those as hole E. And I'm also going to add a comment inside my sequence that says inspect hole E. Now, if I want to CNC probe those, first thing I'm going to see is this. And you can see that with this trajectory, I don't have any risk of collision with the actual part on the model shown with the CAD. If you want to make sure, you could always increase the clearance before, so I could make it a little bit wider, maybe 30 or 40 millimeters. So now if we do that, you can see that I have less risks of collision. And probably those parameters are good. Don't forget about the max depth, in this case, 10 millimeters. So that's going to be measuring this hole. So that's fine. I could go with CNC probe on this one. So let's get started. So this one has been probed. We'd be ready to do our next circle. Now, for circles, let's take a look at additional parameters we haven't seen yet. So typically, the location of the hole will influence where the measurement points will be located. For example, this hole that we're currently looking at is actually at the bottom of the corner bore, the smaller one we have here. So instead of saying that the circle is on top, it's actually at the bottom. And in this case, what this changes is the location where the measurement point will be located. Now, there's two series of measurement points in this case. The measurement points for the local plane, the measurement points for the circle. The measurement points for the local constraining plane are controlled by the set of parameters that are here. We have 3 of them, which is fine, and currently they're at a certain offset from the circle. Now, this little surface being very narrow, 2 millimeters is too much. So I'm going to go with 1.25 maybe. And you can see now my points are on the top surface where I need them. Now, in addition to that, I also have my measurement points for the circle. And currently, they're actually taken higher than the circle. And again, this is a very shallow counterbore. So in this case, 2 millimeters, which is the offset to where our constraining plane is too high. So I'm going to go with 1.3 maybe, and let's see where that puts us. 1.3 is a little too high, so we can go with 1.2 maybe. Still a little too high, so let's go with 1.1. Remember, I'm using a 2 millimeter probe here, so it might be tricky to go with 1 millimeter as the offset. And finally, with this being done, one of the parameters I haven't taken the time to explain yet, of course we can control if we're going to measure counterclockwise or clockwise, but there's something about movement type that was hard to see before. You can see right now that optimally for holes, we're using linear movement type when it's set to automatic, because this is the shortest path to each point. But you could also use circular movement types that will allow you to move in a circular motion. Note that if we were dealing with a pin or external holes or circles, we would have automatic to be circular instead of linear. So the in-space orientation drives the movement type on circles, cylinders, and all curve-based features. So in this case, I think all our parameters are good, so we can launch our measurement. So we're first measuring our constraining plane, and then our circle. So our circle has been measured, and now we're ready to for the next circle, where this one, instead of being located at the bottom, is actually at the top of the circle. So this is okay, and you can see your constraining plane measurement points are positioned adequately thanks to that. But this time I'm going to reduce the tangent offset to maybe something like 1 millimeter. 3 points is enough. And when it's time to set the measurement points for this, they actually have to be a little bit less deep, I would say. So maybe 0.5 millimeter. And you can see now our measurement points are properly located here. So let's go and measure this. So it's measuring the constraining plane. And finally, and we have our circle that has been measured. Now, we want to measure the next circle, this one. And this one's particular. In the counterbore, you can see that we don't have any sidewall on this side here because of the shape of the surface it lies on. So here's where I'm going to use the start angle and the angular range to control what I want to measure. So in this particular case, the hole is located at the bottom of the counterbore. Our constraining plane points appear to be located where I need them. And the problem I have is with those measurement points that I have here for this, as number 6 and number 5 fall in the void space. So there's no way I'm going to be using this to measure. So instead of manually dragging them to reposition them, I can also use the start angle. So in this case, if this is my first point that I'm measuring here, I probably want to rotate that using the right-hand rule again. So it would come to another location, maybe here. So let's say I want to measure over 200 degrees. So I would probably go with a start angle of, let's say, 100. So as you can see, my first point, number 4, is now here. A little high. I can always change that. So I can reduce the height. So it's at, let's say, 1.2 instead of, so this is OK. And now I would be measuring over 200 degrees instead of the default 360. And I would probably invert the direction. So in this case, you can see that my first point will be taken here, second point over here. So it's point number 4, point number 5, and point number 6. So now this would be ready for me to probe. So now, as you can see, I'm done probing all those features. And if we wanted to, here in this case, we've added all the steps because we were recording, which is probably the simplest way of creating our sequence. But if you want, and with experience, you might be interested in stopping the recording and performing the steps manually and then add them to the sequence, either by dragging or by inserting using the right click in the sequence. So it's up to you to decide how you want to do this. But what we could do right now is actually plan for inspecting the next hole, which is hole D, a little bit like what's illustrated on the drawing here. We're going to measure those, but this time, by doing this, we're not going to record the steps. We're rather going to integrate each measurement one at a time and execute it step by step. So right now, what I'm going to do is simply insert a comment where I'm going to say I'm inspecting hole D. And of course, we need to plan for our tool to be changed. So in this case, my probe's over here. I could have a go-to that would send it to a safe location. But right now, I know that by changing to the other orientation, I should be OK. So I will leave things the way they are. And finally, if I want to integrate a tool change, I can either do it by inserting the operation. So I go Tool, Orientation. I can pick the orientation I would like to use. So again, green means I do have this orientation. So it would be this one. And once the orientation is there, I can actually bring my cursor on top of it and execute this step by pressing the execute next step. So if I do that, the orientation has been changed. And now I would be ready to move to the position to probe those. So first of all, I would be creating my features. So I'll start with hole D. Then I will go with the next circle. And this time, let's say I don't want to reprobe this plane twice. I'm going to create a plane feature over here. And I'm going to use the plane feature as a constraining plane for both circles that I want to measure. So in this case here, I will group those together. Call that hole D. And I'm going to take the time to define the constraining plane not to be a local plane, but I'm going to use plane 1 that I just defined. And I'm going to make sure I preset everything in those. So datum cylinder D's measurement points will be done from nominal. Right now, everything appears to be good. Depending on where my probe will be, I want to make sure there's no possible collision that can be created. So let me just zoom in. So I can increase the clearance distance before. So by having it longer, I'm safer when I'm moving there. Okay, so I have my cylinders that are created. That's good. Then I'm going to go to the next feature, which is the plane. Now for this one, the plane, I could want to define custom measurement points, which is what I'm going to do. So I'm going to anchor them. Okay, I'm good with that. And then for my circle, I will go like earlier. This time, the circle is on top of the hole, and I want to be able to measure. So 0.5 should be okay. So you can see my points are very close to the edge, but that should be okay, 0.5. So 3 of them, sorry. And the next, sorry. Let me just verify that everything's okay with the next one. Yep, good. And finally, my circle here, the larger one, which is at the bottom, those measurement points seem to be okay. However, you can see it's a little high on this side. So maybe I want either to go lower or just rotate it like I did before. So I'll go with a start angle of 180. And I think that should be good for now. Perfect. So everything's all set. Now, since I'm no longer recording, what I want to do here is probably take all those features and just drag them into the sequence where the marker is. So it's going to add them. And as you can see, those steps haven't been executed. If I do want to execute those steps, I probably want to bring the cursor on top here, and then I'm going to go step by step or by pressing F10. So right now, it's telling me it's going to be probing the cylinder. And as you can see, my probe's here, so it shouldn't have any clash with the part. So then we're probing inside our cylinder. So now that the probing has been done, the measurement step has been executed, which is why it has a green background here in the sequence. And now my marker is just before probing plane 1, which is what we're going to do right now. So we go next. So if you feel comfortable with this method where you're actually dragging and dropping each object you want to measure, that's another way of performing your or creating your sequence instead of recording. So I can go with the next one. And finally, the counter bore. And we're done with the sequence, and we're at the last step at the bottom here where we've just inspected hole D.